I forget to start the recording, you can either remind me or you can start by yourself.
Oh, thank you.
Muhammad Faris.
Yes, doctor. And also, are you going to upload the recording sessions on Microsoft Stream, or the students just upload the recording session on their laptops?
The recording sessions of Microsoft Teams are automatically available after the class for 20 days.
Yes.
So they will be there. You'll be able to access, but make sure you download them within 20 days.
Yes, okay. Thank you.
Nawaf Ali.
Yes, doctor. Will the quizzes in this course, will we have quizzes or like class tests?
No, there will be quizzes. What do you mean by quizzes or class tests?
Meaning regarding the frequency of it and the percentage.
The percentage and 10%, I'll let you know later what will be the distribution. But yes, of course, the major part of this 10% will be quizzes.
Oh, okay, I understand. Thank you.
Any other questions or queries? Okay, there is one question I see in the chat. Are the quizzes common? Mohannad, what do you mean by common? Mohannad or anyone else, if you can hear me, what do you mean by common quizzes?
I think he mean the quiz will be common for all the teachers.
No, because the class timings are different. They will not be common for all sections. There will be different quizzes by different instructors.
Yes.
Okay, how many quizzes there will be? There will be between 5 to 7 quizzes, and at the end of the semester, I will delete 1 to 2. 1 to 2. I promise 1, but I will try to delete 2. Worst 2 for every student. So 1 to 2. Yes, Muhammad Faris.
Yes, and the quizzes will conduct on during the class time, or will be another time.
No, of course, during the class time. Another time is a big mess. We will conduct the quizzes during the class time, inshallah.
Yeah, inshallah. And all the quizzes are written.
All the quizzes are not written. They will be, what do you call that? They will be fill in the blank type.
Yes.
Like a single answer, but not in terms of multiple choice. A
Oh,
blank numerical
yes.
answer. In terms of Blackboard language, you call it, I think, numerical answer.
Okay, thank you.
I think one of the things I missed in this syllabus are the cutoff points. And I think the cutoff points for statistics courses are fixed. I will let you know about, I think I know them. The cutoff points are, I think, like this. I'm not sure, but I think they are like Like 87 plus is A plus. Between 80 to 86.9 there is A. Between 75 to 79.9 there is B plus. Between 70 and 74.5 there is B. Between 65 and 69.9 there is C plus. 60 to 64.9 there is C. 55 to 59.9 there is D plus, and 50 to 54.9 there is D, and below 50 there is F, where I hope no one falls. This I think is the great distribution for all statistics courses. Okay, there are some messages. In fact, if you want to say something, it's better you open the mic, because it's tough for me to go to the chat again and again and come back here. So attendance will be taken automatically. There is one thing which is attendance that is taken automatically, but the class participation, I will ask you questions time to time. That will not be automatic. I will have the attendance sheet open with me, and I will be asking questions and taking note of who is trying to answer. And I am focusing on the word trying to answer, not exactly answering the right. About the free absences, don't worry about the free absences, as long as you're doing good in the course. The level of the course is, it's not easy. It's a level 3 course of statistics. It's not tough and it's not easy. I'd not call it a hard course, but it's not easy by any way. The course is actually packed with many contents. So it's a lengthy course, but not tough. I would call it a lengthy course. So you'll face troubles in covering all the material in final exam. Midterm would be fine, but final exam you'll have too much material. Okay, let us start this course by the word statistics. Of course, this is name of the subject, and it is a science like all other sciences. So what do we do in this science? We make decisions. How do we make decisions? We make decisions based on numbers, based on, what do you call that, data, available data. You look at the available data, you draw conclusions from the data and make decisions based on those conclusions. So statistics basically is a science of what do you call that, making decisions. Of course, under uncertainty. based on data. So you will have a set of data, and based on that data, you'll draw conclusions and make decisions. Now, once I give you the data, I will leave two jobs for you, two branches of statistics for you. There is one branch that is called descriptive statistic. And there is second branch which is called inferential statistics. And in between the descriptive and inferential, there comes the concept of probability that bridges the two concepts. Now, this descriptive statistics will be covered in the lab, your lab class. This course will be started with the concept of probability. We will introduce the concept of probability. In the meantime, you'll be covering descriptive statistics in the lab parallel. So once we are done with the descriptive statistics and probability concepts, we will move from descriptive to inferential using the probability concept. Now, about the descriptive and inferential statistics, you just need to look at the words. If you look at the word descriptive, the word is coming from describe. So this whole thing is about describing the data. You have the data, you need to describe the data in terms of average, in terms of variance, and in terms of many other measures. So having the data and just describing it in terms of the center or in terms of how much variation is there in the data, that's called descriptive statistics. A very small example of descriptive statistic is what I give you the data on a variable X. The data is 2, 4, 2, 5, 6, 9, 7. Let us say this is the data set with 7 values. And from this data, I ask you what is the minimum value of X, which is 2. That's describing the data. This is descriptive statistics. What is the maximum value? That is 9. Also, X maximum is another descriptive statistics. What is the average value? You add them and divide by 7. That's the descriptive statistics. So there are many descriptive statistics like minimum, maximum, average, median, variance. You will study all of them in your lab course. So if you stick yourself towards only describing the data, I'll write this word, describing the data. The word descriptive comes from describing. Only describing the data. But if you go one step further from describing, not only describing, but also making decisions based on this data, that part is called inferential statistics. So if you're confused about the branch inferential, the word explains itself. Inferential word comes from infer. Does anyone know what is the meaning of infer? Infer is another word coming from refer. Infer or refer. So in inferential statistics, you will be making decisions about the bigger part based on the sample. So you will have a sample of some individuals from Saudi Arabia, and you will be talking about whole Saudi Arabia based on this small part of Saudi Arabia. So you will have a sample from Saudi Arabia. You will be referring to whole Saudi Arabia based on this small part of Saudi Arabia. So you'll be making decisions about whole part, which we would call in this course a population, a bigger part, a totality. So you will be making decisions about the whole thing based on a small sample. That branch of statistics is called inferential statistics, where we refer to the bigger part based on the available information.
Doctor?
Yes, Nawaf.
So is it like generalization?
Yes, it is like generalization to a bigger part based on a sample.
Okay.
A very common example is like one of the students from this class, he asks me, tell us historically what is the average GPA of STAT 319 course historically, and for all the students, for all the past students, for all the current students, and for all the future students. So my population is all the students of STAT 319 who have taken this course in the past, who are taking this course, and who are going to take this course in future. All those students of STAT 319, that's my population. Now, for obvious reasons, I cannot study whole population. Sometimes because of the lack of availability, future students are not available yet. Sometimes because of the lack of resources, I don't have enough money to study all of them. Sometimes because of convenience, I cannot go back in the past and maybe get the data for past students. So what I would do is I would take a sample of some students which are convenient, or this is another topic of how to take the sample. I will not go into this topic, but I will pick some of the students based on convenience or whatever reason. I will pick some students. And let us say those some students, they came out to be, let us say I have 5 students and their scores in STAT 319 were like 69, 82, 77, 61, and 73. Let us say 5 students I picked, these were their scores. So if I am interested in average score of STAT 319 course, I will take the average of these 5 numbers. The average of these 5 numbers will be what? That is 72.4. Now, what I will be saying is that the population, the average score of STAT 319 for all the students is around 72.4. So I'm talking about the whole STAT 319 students based on a very small part of those, based on these 5 students. So I'm referring to the population based on this sample. This is called inference. This is called inferential statistics. And between inferential and descriptive statistic, I want to see how much variation in this 72.4 can be. If I take another sample of students, obviously I will not get 72.4, I will get another number. So I want to see how much that number can be different from this number. In between, there will be a concept of probability. So based on this probability distribution, I will decide how I'm going to refer about the population. So to summarize the things, we go back to the definition of statistics. Inside the definition, you will see there are two branches. In statistics, what we do is we make decisions based on the data. And before we make decisions, we describe the data. So while making decisions, one of the branches, one of the basic things we do in this course is we describe the data. And once the data is described, the next step is to make decisions based on this data. We make decisions about the population based on the sample. So this inferential statistic is about inferring to population based on sample. Based on the limited available information, you will be inferring or referring towards the population. Now this is your chapter 6. Let me This is your chapter 6. This is your chapter 2, 3, 4, 5 is not in this course. Yeah, 2, 3, 4. And this is your chapter 7, 9, and 10. So this course we will start with chapter 2, and in parallel your lab course will start from chapter 6. Now in this course we will be handling all the problems manually, like calculating the minimum of the data manually, calculating the average of the data manually. And in the lab course you will be doing exactly the same thing but on Minitab. So probably after finishing chapter 6, obviously chapter 6 you will do in the lab manually first. After finishing chapter 6, you will start your Minitab in the lab course. Any question up until this point? I will formally start chapter 2 after this introduction.
Doctor, could you please upload the syllabus in the Blackboard?
Yes, I will upload syllabus on the Blackboard. I will upload everything on the Blackboard, don't worry.
Thank you, Doctor.
Doctor?
Yes, please go ahead.
In regards of these chapters, do you recommend studying from your lecture notes and the videos, or from the book when we get it from library?
I would never recommend you not to go towards the book. I always recommend you to refer towards the book. But if you want to see the summary, I will upload my lectures also. My lectures will summarize the thing, but everything will be there in the book. For any situation where you are stuck somewhere, you can always refer to the book. Book reading is always good. Always good.
Understood. Thank you.
But I hope that after looking at the lectures, if you read the book like in 10-15 minutes, you read the section, you will be able to understand everything. And of course, the lectures are designed from exam point of view, and the book is designed from a learning point of view. So it is always good to look at both of them. Okay, we are going to start chapter 2 now. And your chapter 2 is probability. And before I move on to probability, I want you to understand some of the basic definitions that we are going to use while defining probability. Before I define probability, I want you to understand what is an experiment in terms of statistics. Obviously, experiment in terms of other sciences is something different, but in terms of statistics, what is a random experiment? In terms of statistics, a random experiment, it is a procedure. And usually in statistics, you will be talking in terms of numbers. It will not be an experiment like you put one chemical and you put another chemical and you see what comes up. Statistics will be majorly based on numbers. So you will have the experiments like the outcomes will be numbers. So a random experiment is an experiment which you perform. And if you perform it, the result is a number which is unpredictable. Before performing the experiment, you don't know what is going to be the result. That kind of experiment is called a random experiment. For example, if I pick a student randomly from this class and ask him, what is your current CGPA? So before asking the student, I don't know what is going to be the answer. Of course, I know it will be between 0 and 4, but I don't know the exact number. So a random experiment is a procedure that produces outcomes. Usually in terms of numbers. As I said, in statistics, we will be concerned about the numbers. Its outcome is unpredictable and it has more than one outcomes, obviously. If there is a one outcome, you can always predict. For example, if I ask question to a randomly selected student of this class, what is your gender, male or female? That is not a random experiment. Because all the students in my class are males. There is only one possible outcome of this experiment. So some of the properties of random experiment are what? It will have more than one outcomes. You will not know the outcome in advance. You will only know the outcome after the experiment is done. And the outcomes will be unpredictable. These are some of the properties of random experiment. And every problem, we will describe it as a random experiment. All these definitions will be hidden inside every problem. Whenever you will get a problem from probability, in the background, you will be noticing there is somewhere a random experiment. Once we know what is a random experiment, the next job you need to do is to define a sample space for that random experiment. What is a sample space? It's actually a set of all possible outcomes of random experiment. So you defined the random experiment already. Now you see what are the possible outcomes of this random experiment. You write down all those possible outcomes in terms of a set. That set is called sample space, usually denoted by S. For example, what is your current CGPA? What are the possible answers? You can say 2.7, 3.1, 3.2, 3.9, 2.9. So I expect S to be a set where X is between, I think, 1 and 4. Is it? Can your CGPA be less than 1?
I don't think it's possible.
Is it possible to have a CGPA less than 1? In KFUPM, obviously. I don't think.
Yes.
Is it possible?
Yes, I believe yes. It's possible.
Let me make it 0. Exactly 0, I don't think is possible. So bigger than 0 is possible. So this is a sample space. For what experiment? For the experiment that I will pick a student randomly from KFUPM and ask him about his CGPA, current CGPA. That's the experiment. And this is the sample space corresponding to that experiment. So that is the experiment, and the corresponding sample space is S. You can expect anything between 0 and 4.
Doctor,
Yes.
are the random experiment and sample space related to each other?
Yes, of course. Sample space always comes from the random experiment. You look at the random experiment and you look at what are the possible outcomes of this random experiment. Those outcomes, if you write them in terms of a set, that's sample space.
Yes, clear. Thank you.
If I pick a student randomly from KFUPM and I ask him, where are you currently living? In which country you are currently living? What will be the answer?
Most Saudi Arabia.
Saudi Arabia. Of course, Saudi Arabia. So this is not a random experiment. This is called a non-random experiment where you can tell the outcome in advance, even before performing the experiment. If I join the two circuits and want to know if the current will pass through or not, I join the two circuits. A and B, and see if the current is passing through or not. So I'm interested in yes or no, whether the current is passing or no. Is this a random experiment or non-random?
Where there could be two answers, Doctor?
There can be two answers, yes or no. The current may pass, may not pass.
It's random.
Random.
It's random.
Yes.
Although you know the answers will be either yes or no, but still you cannot say with 100% guarantee whether it will be yes or no. So that's random. And what is the corresponding sample space? It's yes or no in terms of a set. That's the sample space corresponding to this random experiment.
Doctor,
Yes, right.
can we have an infinite set?
You can have infinite set. Let me give you an example of that infinite set. You perform an experiment, that is, we stand on the Dammam Highway Express between 3 p.m. and 12 p.m. midnight and note down the number of minor or major accidents. That's the experiment. By the end of the day, you will have a number. Like today, I saw 7 accidents. Today, I saw 0 accident. Today, I saw 4 accidents, and so on. That's the experiment. Now, first question you ask to yourself, is this a random experiment?
Yes.
Yes, this is a random experiment. Before standing there and before the end of the day, you will not know what is going to be the outcome. This is a random experiment. Once you know this is a random experiment, now you think about what are the possible answers am I going to get? By the end of the day, what will be the possible outcomes?
Zero to infinity?
I may get 0. I may get 1 accident. Can I get 0.5?
No.
So I will not write this in terms of an interval like I wrote here for CGPA. I will not write it in terms of interval. I will write them in terms of numbers. We will talk about these things later. So I will write them in terms of numbers 0, 1, 2, it can be 3, it can be 4, and I don't know up to what.
And this it's called infinite.
I would call it an open set from the right side. Yes, infinite. So there are infinite elements in this set. Obviously, you cannot go negative either. Then we come to the next definition, which is corresponding. This definition is in line with the superset you study in the set theory. Then we go to the next definition, which is called event, and this definition is in line with the subset in your set theory. In your set theory, whatever you call subset, that's in statistics the name is event for that thing. Event is a part of sample space. Any part of sample space where you are interested. For example, I define an event A that the CGPA is more than 2. That is an event. For example, I'm interested. What are the chances my CGPA will be more than 2? So I define it as an event for this sample space. Where is that sample space? This sample space. For the second experiment, I am probably interested in whether the current will pass or not. So I can define an event B that the current will pass. Yes. For the third experiment, I may be interested in an event that there will be no accident. I define an event C. There will be no accident on that given day. Between 3 to 12. So there are different subsets you can define according to your interest, according to the interest of question. And usually these events are denoted by A, B, C, A1, A2, A3, B1, B2, B3. With no hard and fast rule. You can define these events by any letters you want. And finally, once you know what is a random experiment, once you know what is a sample space, once you know what is the event, finally, the last argument is that we find the probabilities of these events. For example, from the first random experiment, I may ask you what is the probability that for the student CGPA will be more than 2? What is the probability that the current will pass? What is the probability of no accident on a given day? Now, the bottom line in exam is that the exam will not tell you what is the random experiment. The exam will not tell you what is the sample space. The exam will directly ask you the question about the probability. You are the one who's going to identify what is the event in this question, what is the background sample space, and where is this sample space coming from? What is the random experiment behind this sample space? From there, you will get the answer of probability directly. So these three things are happening in the background for every question of probability: the random experiment, the sample space, and event. In the next class, I will show you some examples of questions from exams, and I will tell you how to identify from those questions what is the random experiment, what was the sample space, and what is the event, and how to proceed with the final answer. This is where I stop in this class. If you have any question from today's class, you may go ahead now. If you don't have a question, you can leave the session at this point. Muhammad Ali.
Are we going to have a lab today?
According to the lab that I'm teaching, is there a class on Sunday? I think there is no class on Sunday. If you are registered with another instructor, you can check with him. For me, I think I don't have a lab on Sunday. Let me check.
Doctor, I think he is mean in general. Is there a first lab or not?
In general, there is a perception that the first lab is an off, but I think that tradition is over now. We used to have tradition of giving off for the first lab, but I think there will be. If there is something, I'll let you know through the Blackboard announcement. But I think that tradition, which was a good tradition, that tradition is over. We used to give first lab off, but in summer we already have a small time window, so I don't think there will be any off for the first lab session. Tomorrow I have a lab session, so I hope there is a lab session tomorrow for my section. For other sections, you can confirm with your instructor.
Okay, thank you, Doctor.
And again, I